Hi everyone, welcome to the Data Analytics and Visualization Part 2. This is advanced version of Data Analytics and Visualization Part 1. My name is Dr. Himmat Alisha, your course instructor. The purpose of the course is to build on your existing knowledge of data analytics and visualization. We will explore more advanced techniques for analytics, databases, identifying trends and patterns, and transform raw data into meaningful insights. This focus will not only be on performing analytics only, but also communicating results clearly through effective visualizations. What students will learn through this course: you will learn how to prepare and clean the data and perform exploratory data analysis, apply analytical methods to real world problems, and create professional visualization using Power BI dashboards. We will also learn with various data sets and tools to develop practical skills that can be applied both academics and professional environment. A key aspect of data analytics is the ability to tell a story within a data. Even the most accurate analysis has a little impact if finding cannot be understood by the decision makers. This is very important. So therefore, we will learn how to design visualization that are more clear, effective, interactive, informative, and engaging, that help users to understand complex information and make better decisions. So please keep watching. Okay, so let's discuss the course module 1. In this module, we will cover the basics of data analytics, like what is data and types of the data, and introduce about the data analytics and visualizations, the basic definitions of the topic, and then we will jump into the NLP, natural language processing, and then we check the business cases and the challenges of unstructured data. There are two types of the data: structured data and unstructured data. Unstructured is heterogeneous data, and structure is a homogeneous data. Then we will find NLP techniques and introductions, and then we use NLP use cases. Then we will jump into the two important applications of NLP: keyword extraction, D rank and H rank, keyword extraction methods, both language dependent and language independent methods. And then we do some basic exercises using NLP basics operations using programming. So let's dive into the course. So let's start part one, where I will introduce myself and also provide you the detailed outlines and topics that we are going to cover this course. In part second or part B, we will cover the NLP based on the businesses perspectives. So first part was general NLP introductions and basics definitions for the data analytics. But part two of NLP, we will cover the business aspects, and we understand unstructured data, text data, business text sources, reviews, emails, social media surveys. And then we will cover the importance of NLP in data analytics, and we'll cover a case study of 1,000 customer reviews. And then we go through the sentiment analysis and its business impact, followed by ticket categorizations like TF, IDF, ML models, BERT, trend extraction, automated report generation, and business benefits. So, quite interested first model we will try to cover in this course. So, keep watching. For the requirements of the course, you need to install Python and also use Jupyter Lab, Spider, and maybe you can use VS Code. If you don't know how to program, please learn basics of the Python and Power BI. If you are business students, don't need to do programming. Just follow the lectures and you will understand. And for the assignments and projects, you need to return the PDF copies. and also share the Power BI dashboard, CSV file, or that PDX file. Next.
Books for this course. I recommend several books that provide both theoretical knowledge and practical experience in data analytics, artificial intelligence, and data visualization. These resources will help you strengthen your understanding of modern analytical methods and industry practices. The first book, Analytical Skills for AI and Data Science by Daniel Vaughan, focuses on developing the analytical thinking and problem-solving abilities required in AI and data science projects. It emphasizes how to ask the right questions, interpret results correctly, and make data-driven decisions. These skills are fundamental for anyone working with data. The second book, Data Analytics and AI, explores the connection between data analytics and artificial intelligence. It provides insights into how data is collected, processed, analyzed, and transformed into intelligent systems. This resource is particularly useful for understanding how analytics supports modern AI applications and business innovation. The third book, Starting Data Analytics with Generative AI in Python, introduces practical approaches to data analytics using Python and the latest generative AI technologies. As AI-powered tools become increasingly important in data analysis workflows, this book helps learners understand how to leverage these technologies to improve efficiency, automate tasks, and generate insights more effectively. While these books are not mandatory reading, they serve as valuable references throughout the course. I encourage you to explore them whenever you want deeper explanations, additional examples, or practical guidance beyond the lecture materials. Combining the course content with these resources will help you develop a stronger foundation in data analytics and visualization. Remember that becoming proficient in data analytics requires continuous learning. Reading, practicing with real datasets, and experimenting with different tools and techniques are all essential parts of the learning journey. These books provide excellent support as you develop the analytical and visualization skills needed in today's data-driven world.
Data analytics is one of the most promising career fields in today's job market. As shown in this chart, many of the fastest-growing professions between 2025 and 2030 are directly connected to data, artificial intelligence, and digital technologies. Big data specialists and AI and machine learning specialists are expected to experience the highest growth. This reflects the increasing demand for professionals who can collect, manage, analyze, and interpret large volumes of data. The highlighted role of data analysts and scientists is particularly important. These professionals help organizations transform raw data into meaningful insights that support better decision-making, improve efficiency, and drive innovation. Data analytics skills are valuable across almost every industry, including healthcare, finance, manufacturing, education, retail, transportation, and government. Organizations of all sizes rely on data to understand customers, optimize operations, and plan for the future. According to the World Economic Forum, demand for data-related professionals is expected to continue growing rapidly over the coming years. This makes data analytics not only a high-demand career but also a future-proof career choice. Through this course, you will develop practical skills in data analysis, visualization, and interpretation that can prepare you for opportunities in this growing field. Whether you aim to become a data analyst, data scientist, BI developer, AI specialist, or researcher, these skills will provide a strong foundation for your future career. Provide your feedback on BizChat.
Now that we have seen the strong demand for data analytics professionals, let's look at another important question. What can you expect to earn in this field? This table shows typical salary ranges for data analytics professionals across different countries and career levels. While salaries vary by company, industry, location, and experience, the overall trend is clear. Data analytics is a well-compensated profession with strong growth potential. At the junior analyst level, salaries typically range from around $38,000 to $85,000 or euros depending on the country. This is the entry point for professionals who are developing their analytical skills and gaining practical experience with data tools and business processes. As professionals gain experience and move into senior analyst positions, salaries increase significantly. Senior analysts are expected to handle more complex projects, lead analytical initiatives, and provide strategic recommendations to organizations. In many countries, senior analysts earn between 55,000 and 130,000 annually. At the lead analyst or manager level, compensation grows even further. These roles involve leadership responsibilities, project management, mentoring teams, and contributing to organizational strategy. Salaries often range from 80,000 to 180,000 per year, with the highest levels commonly found in large organizations and technology-focused industries. Looking at the different regions, the United States generally offers the highest salary ranges, while countries such as Finland, Germany, France, the Netherlands, and the United Kingdom also provide very competitive compensation and strong career opportunities. It is important to remember that salary is only one aspect of a career. Data analytics professionals also benefit from high demand, diverse job opportunities, flexible working arrangements, opportunities for continuous learning, and clear career progression paths. As you develop your skills in data analysis, visualization, statistics, programming, and business understanding, you increase your value in the job market and open doors to a wide range of professional opportunities. The key message from this slide is simple. Data analytics is not only a growing field, but it is also a rewarding career that offers excellent earning potential and long-term job stability.
In part 2, let's dive into the details of Module 1, Introductions to Data Analytics and Visualization. So we start with the definition next. Now let's start by understanding what data analytics and data visualizations are. So first of all, data analytics is the process of examining raw data to discover useful insights, patterns, and trends that supports decision making. For example, a supermarket can analyze sales data to identify its best selling products and understands customer buying behavior. Another example is in healthcare, where hospital people analyze patients' data to identify diseases, trends, and improve treatment planning for the patients. Data visualization is the process of presenting data through charts, graphs, dashboards, and maps. So that information is easier to understand, at least not boring information. For example, instead of reviewing thousands of sales records, a manager can quickly identify trends using sales dashboard or bar chart. Together, data analytics and visualizations help businesses, engineers, researchers, and organizations to make informed decisions based on data rather than assumptions. Throughout this course, we will learn how to analyze data and communicate insights effectively through visualizations. Keep remember this is data analytics era. As we discussed in the previous slides, organizations are generating massive amount of data, creating a strong demand for data analytics professional role. But an important question is, where is all this data stored and processed? Today, most organizations rely on cloud platforms such as Microsoft Azure, Amazon Web Services, and Google Cloud. In fact, a large majority of companies store at least part of their data in the cloud. One major reason is that scalability. As this data grows, companies can easily increase their storage and computing resources without investing in expensive physical infrastructure. This also enables real-time analytics, allowing organizations to analyze data as it is generated. Another key reason is that cloud platforms support advanced technologies such as AI, machine learning, and large scale data processing. These technologies require significant computing power, which the cloud can provide on demand. Now that we understand where data is often stored, let's look at the data analytics process itself. The first step is a data collection, followed by cleaning and exploration. Data may come from databases, websites, census, social media, or business systems. Before analysis, we must clean the data by handling missing values, correcting errors, and ensuring data quality. This is called data normalization, and also removing duplicate values. For example, if a retail company collects customer purchases data, analyst needs to remove duplicate records and check for incorrect entries before starting the analysis. The next stage involve data storage, modeling, visualization, and reporting. Analysts use various tools to organize data, apply analytical methods, and create dashboards or reports that help stakeholders to understand the result. For example, a company may create a dashboard showing monthly sales trend, customer behavior, and product performance. The actual and final goal of the data analytics is simple: turn raw data into useful information for decision making. The value of analytics is not in the data itself, but in the actions and decision that results from the insights. Whether it is improving sales, reducing cost, optimizing operations, and predicting future trends, the ultimate objective is to use data to make better and more informed decisions. Now that we understand the key elements of a data analytics process, it is important to recognize the data analytics, which is not always straightforward. Organizations or companies often face several challenges when dealing with the data. One more common challenge is data quality. If data is incomplete, incorrect, or inconsistent, the result of analysis may be unreliable. Second challenge or another challenge is data integration, where information comes from multiple sources and must combine into unified data set. Data security and privacy are also critical, especially when handling sensitive data or customer information, for example, healthcare or financial information. To manage these challenges, analysts follow a structured analytic life cycle. That is, process typically begins with discovery, where the problem and objectives are defined. Next comes the data preparation, where data is collected, cleaned, and organized for analysis. After that, analysts build models and perform analysis to uncover insights that the results are often evaluated to ensure they are accurate and useful. Finally, the solution is deployed, allowing organizations to use insights in real world decision making. Remember, it is important that analytics always is not one time activity, it is a cyclic and iterative process. As the new data becomes available, analysts revisit earlier stages, refine models, and generate updated insights. So, this continuous improvement process helps organization to make better decisions over a time. Next, we discuss the types of data analytics. There are four main types of data analytics: descriptive, diagnostic, predictive, and prescriptive. The first type is descriptive analytics, which is the basic form of this analytics. It summarizes historical data through reports, dashboard, and visualization. For example, a company may analyze last year's sales figures to understand performance trend. So it checks past previous figures and history. Next, we move to the second type of analyst, that is diagnostic. Why did it happen? Here we investigate the cause behind the event and trend. Techniques such as drill down analysis, correlation, and root causes analysis help identify the factors that contributed to the particular outcome. For example, if sales dropped in a specific region, diagnostics analytics help uncover reason. The third type is predictive analytics, which focus on future by answering what will happen in the future. Using historical data, statistical models, and machine learning algorithm, organization can forecast future outcomes. Example including predict customer demand, predicting a restaurant customer, how many customer will visit tomorrow, equipment failure, or students' performance. And last, now let's discuss the final prescriptive analytics, which goes one step further and answer what should we do. The types of analytics provides recommendations for optimal action or best action based on the predictions and business objectives. For example, logistics companies may use prescriptive analytics to determine the most efficient delivery routes or inventory level. As we move from descriptive to prescriptive analytics, the values and complexity also increases. Organizations that successfully leverage all four types that can make smarter, faster, and more strategic decisions.
Different types of analytics. Let's look at the tools and techniques that data analysts commonly use in practice. The first category includes tools for data management, querying, and visualization. Popular examples are Microsoft Excel, SQL, Tableau, Power BI, Altair, and RapidMiner. These tools help analysts collect, organize, explore, and visualize data, making it easier to identify trends and communicate insights to decision makers. The second category focuses on programming and statistical modeling. Languages such as Python and R are widely used for data cleaning, data analysis, visualization, automation, and building predictive models. These tools provide flexibility and are essential when working with large datasets or advanced analytical tasks. The third category covers advanced techniques such as data mining, machine learning, and cloud platforms. Data mining helps discover hidden patterns and relationships within data, while machine learning enables systems to learn from data and make predictions automatically. Cloud platforms such as Microsoft Azure, AWS, and Google Cloud provide scalable infrastructure for storing, processing, and analyzing massive amounts of data. Together, these tools and techniques form the foundation of modern data analytics. Organizations often combine multiple tools depending on their business needs, data size, and analytical objectives.
Next, we discuss about anatomy of data project. Before we walk through the stages of data project, let's first discuss and understand the important concept of data wrangling. Data wrangling, also known as data preparation or data cleaning, the process of transforming raw data into clean, structure, and useful information for analysis. In reality, data is often messy, we know. It may contain missing value, duplicate record, inconsistent formats, or error. Data wrangling help us to fix those issues before analysis begins. Common data wrangling activity include cleaning data, handling missing values, removing duplicates, transforming formats, integrated data from multiple sources, and organizing data for analysis. In fact, data professionals often spend a large portion of their time on data wrangling because high quality analysis depend on high quality data, of course. As the saying goes, garbage in, garbage out. Now let's see what data wrangling fits within overall life cycle of data project. So let's begin the main core topic, anatomy of data projects. So first step is to define the problem. Every successful data project, yes, so every successful data project starts with very clear defined problems or objectives. We need to understand the business need, research question or challenge we are trying to solve. For example, including reducing number include reducing customer churn, predicting sales, improving product quality, or optimizing operations. Number two, now second is collection and cleaning data. Once the problem is defined, we gather data from relevant sources such as databases, spreadsheets, sensors, website, APIs, or cloud platforms. After collections comes data wrangling, where the data is clean and prepared. This includes correcting errors, value removing duplicates, standardized format, and combining data sets. The goal is to create a reliable data set that can be trusted for analysis. Third is explore and model. With clean data available, we begin exploring it to do identify trends, patterns, and relationship. This stage is often called exploratory data analysis, called EDA. Based on the finding, statistical techniques or machine learning models can be developed to answer the original problem and generate insight or predictions. Validate and visualize. Fourth number. Before presenting result, we validate our finding and test result or models to ensure they are accurate and reliable. The insights are often communicated using charts, dashboards, reports, and visualization. Effective visualization help stakeholders, businesses, to understand complex information and make correct, useful information decisions. Finally, deploy and monitor. The final step is implementing the solution in a real world environment. For example, predictive model may be integrated into website, mobile application, or business processes. After deployment, continuous monitoring is essential, checking, rechecking again to ensure solution continues to perform well as new data becomes available. Models may need regular update and retraining to maintain accuracy. Data project is not simple about building model. It is a structured process that starts with understanding the problem, preparing high quality data through data wrangling, extracting insight, communicating results, and finally deploying solution that create real business value. Let's now explore open data. Open data is the data that anyone can access, use, reuse, and share freely. It is a publicly available and designed to encourage learning, research, and innovation. Common sources for open data include government agencies, university research institutes, and the open data portals or platforms. Examples include weather data, transportation data, and census data and environmental data. Open data also promotes transparency and innovation. Governments can improve accountability by sharing public information, while businesses and researchers can use that data to develop new products, services, and insights. While business and researchers can use the data to develop new products, services, and insight. For data analytics, for data analysts, open data is valuable resources for practicing analytics skills and solving real world problems. So, key takeaway from this slide is open data is freely available information that supports transparency, research, innovation, and data driven decision making. Now let's look at some example of open data sources and how we can access and analyze these data sets. Yes, some well-known example for open data set including number one, Kaggle data set for machine learning and analytics project. Then we have a World Bank open data for economics and development indicator. Then we have EU open data portal for European public sector data. In Finland, we have Statistical Finland for demographic and economic data in Finland. And UCI is one of the famous machine learning repository which provides data sets commonly used for research and teaching. These data sets allow analysts to practice data wrangling, visualization, predictive modeling, and machine learning using real world data. Now, let's discuss the big data and deep learning. Is the amount of data generated worldwide. Traditional tools are often not enough to process and analyze it. It brings us to concept of big data and deep learning. First of all, big data refers to data set data too large, complex, or fast moving for conventional data processing method. Big data is commonly described by three Vs: volume equals huge amount of data, velocity equals to data generated at high speed, and variety equals to different types of data such as text, image, videos, and sensor data. To extract valuable information from this massive data, we often use advanced AI tools and techniques. One of these techniques is deep learning. Deep learning is a branch of machine learning that uses AI neural network with many layers to automatically learn patterns from data. Deep learning has achieved remarkable success in areas such as image recognition, speech recognition, chatbot recommendation system, and large language model (LLM) like ChatGPT and Copilot. The combination of big data and deep learning enable organizations to solve complex problems, automate decision making, and create intelligent systems that continuously improve as more data become available. Big data provides the massive amount of information, while deep learning provides advanced algorithm that can learn from the information and generate valuable insights. The third part of this lecture, part 1, part 2, and part 3, we will cover in next video. Thank you for watching.